Hello everybody, so I'm very happy to be here to be talking to you about Tournesol and the vision of Tournesol, which is a future where the web could be collaboratively governed, as opposed to today, where a few entities have a huge power over the flow of information worldwide. So before discussing our vision and how we started to build a secure system for collaborative governance, I want to stress the problem that we are addressing and how big of an issue it is. So to illustrate this, I'm going to start with this quote by Ilya Lovosky, who's by Lev Gershenson, sorry, who's the former head of news in Yandex, so the Russian Google. After the 6th day of the invasion of Ukraine by Russia, he wrote that today is the 6th day that on the main page of Yandex, at least 30 million Russian users are seeing that there is no war. Every day, an hour of such news costs human lives. It's not too late to stop being accomplices of a terrible crime. If you can't do anything, quit. So these are really strong words by one of the leaders, former leaders of the tech industry in Russia. And it really stresses something that I think we should really be aware of, is that as designers of information technologies, we are designing the tools that drives a lot of the information flow over the world. And a lot of the information that many people can be exposed to is highly influenced by the kind of tools that we can be designing. Another thing I would like to stress here is that the issue of what content to recommend is not only an issue between the recommender and between the client. Here we have a case where people who did not participate, who did not engage in the design of the algorithms, nor in the consumption of the content recommended by the algorithms, are going to be affected. What's recommended to Russians on a daily basis is affecting the security of 40 million Ukrainians. And this is something that holds more generally. Like whenever hate and disinformation are spread massively, this affects everyone in the world, especially on topics like, for instance, climate change or war. Now, if you think about this, I want to stress that a lot of the information is driven by recommendation algorithms, that these algorithms have become a geopolitical player in themselves. They have become extremely influential. And to really illustrate this, whenever someone is searching for information about, for instance, here I took the example of vaccination on the internet, then today, like, it's going to be an algorithm that's going to reply to them. And the decision about which content to recommend first, which content to recommend second, and perhaps even more importantly, which content not to recommend, is going to be deeply influential on a societal level. And another thing I would like to stress is that it's actually very, very hard to really know what it is that should be recommended to search a question. So if you think about someone who's actually searching for this sentence, vaccination kills, on YouTube, especially if you watch YouTube regularly, try to ask yourself what content out of all of the videos that are available on YouTube should be recommended to this person. It's arguably a very, very difficult question. Like, should you go with something extremely scientific or extremely factual that may be boring and hard to understand? Should you go with something that just explains the basics, but like, should you recommend something that will mention side effects? Should you discuss herd immunity, these more sophisticated, more complicated concepts? I think it's a very difficult question. I want to stress that the role of the recommender is absolutely huge. It has become like the leading force today for what people consume, at least on the internet, and like the consumption of the internet is, of course, much of the news consumption these days. So typically on YouTube, so YouTube is huge in itself, like it's 1 billion hours of watch time daily. Actually, this was in 2019, so it has probably blown up since then, especially with the pandemics. But the recommender system, like, to give another figure, like right now, like actually since 2016, there are more views on YouTube than searches on Google. The number of views on YouTube is larger than the number of searches on YouTube. And 2 times out of 3, what people view on YouTube actually results from a recommendation by the YouTube recommender system. So algorithms are really pushing what content people consume. Like most of the views are actually on the phone, so more often than not what happens is that people are actually clicking on the YouTube application on their phone, and then there's content recommended to them on their phone by the algorithm. Actually, the case of TikTok is probably even worse, because like TikTok, like videos just come one after the other decided by the algorithm. And well, TikTok is Chinese. I'm not going to say more than this about TikTok, but this should be of concern. Like, there's so much at stake over what kind of information is promoted. There's clearly a lot of information that the Chinese government would not want you and everyone in the Western world, and especially in the Chinese, in China itself, to see. Especially things around the Uyghurs or around how democracy goes in Taiwan, typically. So there's a lot at stake here. And unfortunately, so far, things have been going very, very poorly. Like right now, the algorithms are designed by centralized entities, so typically companies. And in many cases, they have been shown to promote disinformation and hate on enormous scales. So recently, Amnesty International has recognized the critical role of Facebook's algorithms in promoting violence against the Rohingyas, which is a community in the western part of Myanmar. And they demand that, like, they argue that Meta owes reparation. Here we're talking about genocide, like this has been recognized by the United Nations as well, and they talk about genocide. So it's like tens of thousands of people murdered, rapes, and so on, and more than 500,000 people who have had to move to Bangladesh, to another country. And a lot of this is driven by hate speech, like Muslim, anti-Muslim hate speech, that has been promoted massively by Facebook in this case. This sort of phenomenon is absolutely not restricted to Myanmar. Like the case of Myanmar is well documented, like it's been studied a lot since 2017, so we have a lot of data about this, but this is happening in so many countries around the world. I could talk about Ethiopia, I could talk about like Yemen or India, and in the case of Western countries, the issue is more like the rise of radicalism and extreme views. I can mention the United States, Brazil, but even like the UK or many other countries. And the role of Facebook has been really exposed, not only by Amnesty International and the United Nations, but also by all sorts of journalists, and more specifically by the Facebook files. So I don't know who here has heard about the Facebook files. Okay, and who has like spent like hours reading through the Facebook files? Yeah, not a lot. So the Facebook files are extremely compelling. Like they really show that Facebook engaged and designed new algorithms that really changed the landscape of what was widely recommended by the algorithms. That really showed that hate speech, in particular, and disinformation was much more propagated after they changed the algorithm in 2018. And the Facebook teams realized it, they knew this, and they rejected all of the proposals by the integrity team to modify the algorithm to reduce the spread of hate. And this was after the Rohingyas events in 2017 that was already exposed by the United Nations. So here we're talking about like millions of people being endangered. In fact, in India alone, if you count the Muslim people in India, this is already 100 million people that are endangered by the widespread of hate speech in particular. And of course, like in the case of the United States, we have seen the Capitol riots. So like even like at state level, risks of potential upheavals. So that's should be really concerning. In fact, even in solid democracy, so arguably, so I live in Switzerland, so arguably Switzerland is one of the most stable democracy and the most solid democracies in the world. But even in Switzerland, the rise of disinformation and hate has caused a lot of issues, especially around the anti-vax movements. For instance, so it was like 6 months ago, the head of the vaccination commission in Switzerland was kidnapped by an anti-vax activist. And you also see social movements that are using more and more violence, even in Switzerland. If you think about this, like this is not actually only an accident. There's a lot of reasons for authoritarian countries to promote this kind of instabilities in democracies. And it's already been shown repeatedly that like Russia or China have a lot of disinformation activities to try to like cause chaos in democracies. So, for instance, a figure that's really astonishing is that out of I think the 15 Facebook groups, Catholic Facebook groups in the US, that are the largest, the 15 largest, they are all controlled by foreign countries. Like actually, the administrators are from like Russia, typically, mostly Russia, actually. So this should be really concerning. Like this is a way for authoritarian countries to seed chaos in democracies. And of course, like the worst case scenario is that everything just keeps on, like violence keeps being normalized, and then this can go into huge chaos. So I don't know if you knew about this, but like Log4j, so the critical vulnerability on Log4j with arbitrary code execution, this was found by Chinese software developers working at Alibaba Cloud, and they reported the incident directly to Oracle. So they did arguably the right thing, the secure thing, the collaborating thing. But then they got a contract with the Chinese government suspended because of this. In particular, the Chinese government was saying that you should have reported to us before reporting the vulnerability to Oracle. So like this is like the Chinese government like explicitly engaging in cyber warfare, with all of the risk that if you have this vulnerability and nobody else has it, if you have this 0 day on one of the on an extremely used package in Java, then you can break a lot of systems in democracies. You can paralyze a lot of systems, and this can be extremely dangerous. More generally, like the spread of hate on a global scale means that maybe even the Chinese people is more and more, or at least the Russian people, can feel more and more oppressed by through disinformation means. They can feel more oppressed by the Western countries and be more willing to do things that would hurt all sides, and this should be extremely concerning. So I want to stress that these large-scale algorithms, like many of them, are now based on machine learning. So like my background is I've worked a lot on the security of machine learning. And one thing that you really need to keep in mind when you're doing machine learning is that data is critical. Like data is really driving your system. In a sense, in a machine learning system, the code is mostly written by the data. Like the software developer is only writing a few lines of codes. But these systems have like typically millions, if not billions, if not now trillions of parameters. So you can think of them as lines of code. And most of these lines of codes are actually driven by the data rather than by the software developer. And this leads to terrifying behaviors. So typically this is a famous example with GPT-3, one of the most known language models out there. Whenever you prompt it with something about the Muslims, you see that GPT-3 systematically completes the sentences with things like terrorism or at least violence. So you can see like here he's talking about terrorism. And this should not be surprising because there's a huge amount of anti-Muslim disinformation going on throughout the world. And as a result, these algorithms which are trained to learn from what's out there, what's on the web, they're going to have the same kind of behavior as most data out there. So if most of the data is being racist, then you should expect these algorithms that learn from this data to also be, in this case, very biased against the Muslims. Now, to measure the security of these systems, we have to ask ourselves, how secure is the data that these companies train their algorithms on? So one typical question that anyone developing these algorithms and who's a little concerned about security should be asking is, what is the number of fake accounts that are producing this kind of disinformation out there? So what do you think is the number typically of fake accounts that Facebook reports to remove every year? What is the order of magnitude? Do you think it's like thousands, hundreds of thousands maybe? Yeah, so the answer is billions. So like you have many sources for this, but essentially it's now around 7 billion per year. So 7 billion fake accounts per year. It's more, like, it's the population of Earth. So it's more than the number of genuine accounts. So on Facebook, which tries to have one user, one account, most accounts are fake. And that's what Facebook reported. It's very hard to know how they can distinguish most of the time a genuine account from a fake account. I'm guessing that most fake accounts are easy to detect, but when you work this, like you try to do a genuine fake account, like a fake account that looks real, then you can of course make it's going to be much harder for Facebook to detect it. Another question we may ask is like, how many Chinese people in the world, how many Chinese people are paid to produce this information? What is the scale of this? So there's a report by the Institut de Recherche Stratégique des Communautaires, so a military strategic research institute in France, that has reported that they found, like they estimate that there are 20 million people in China who are paid to produce this information. 2 million people in China in full time. So that's the kind of disinformation we have to protect societies against. And unfortunately, so far, like the companies who are in charge of these algorithms, or like Google, Facebook, and so on, are not taking this seriously, nowhere near enough. So you might have heard that Google has fired its ethics team, like Timmy Goboon, Margaret Mitchell, and lots of the others are leaving Google. And Facebook has done the same recently, so that's really reassuring. And so we need we need something else. We need to control a lot more this flow of information and to secure these systems, which are today extremely opaque, unitary designs, and with very, very essentially no democratic control. So the idea that we propose is to have an alternative system, which we call Tournesol, which we have been developing over the last 2 years and a half, which aims to do the recommendation work in a collaborative manner. So essentially what the recommendations made by the Tournesol platform are going to be based on what our contributors, anyone can be a contributor on the platform, will want to promote on the system. So typically it's about identifying top quality videos to recommend on a large scale. Because we believe that fighting disinformation by removing them is essentially hopeless. There's so much of this, and it's so sophisticated. Like there's literally millions of dollars, if not billions of dollars today that are invested in trying to create this disinformation. And we believe that the better way to fight all of this is to replace this by top quality content that typically are going to educate people in how to better deal with disinformation, but also that are going to push the most pressing issues of today, like, I don't know, like climate change or like dealing with the pandemic. I guess this was more relevant, an example that was even more pressing last year. And another thing is typically like the role of these algorithms, I think, is hugely neglected today, and they should be given a lot more attention. So what you can do as a contributor, so if you want to contribute to Tournesol and like improve the quality of information that's recommended to billions of people, what you can do is to go on Tournesol, and what you will be asked to do is to select videos on YouTube that typically you can select the best videos you've seen on YouTube and import them on Tournesol. And then what we ask you to do is to put yourself in the shoes of the algorithm. And so typically you would have to recommend videos. And the question we ask is, out of 2 videos, which one do you think should be more recommended? So we take this comparative approach because we believe that this yields like better data, like more fine-grained data, more precise data that are less susceptible to like changes in how you value, or like maybe some people tend to put 5. So I saw the scores of the talks typically at Devox, and there's a saturation phenomenon that's going on. So like the fact that when you really like a content, you put 5 stars out of 5 stars, but this prevents you from really being comparing 2 content that have 5 stars. And you may want more details in how you compare like these videos that are very good, but like still some of them maybe are talking about more pressing issues. Now, and then based on these inputs from our contributors, we make recommendations based on essentially we generalize, and also we have some security guarantees, which I will be talking about, that allows to make safe recommendations. And if you use our extensions for Google Chrome and for Firefox, then you can have the recommendations by Tournesol directly on your YouTube homepage. So you have typically a panel here with the top recommendations. Also, you can see the scores and the number of comparisons and contributors that the scores are based on. And then we also have a lot of partnerships, like a lot of connections with academia. So I come from academia, and there's a lot of research going on around Tournesol. And one of the things we're trying to promote is to promote the research that is studying this kind of data set, this kind of human judgments of what should be recommended on a large scale. So all of the contributions by our contributors that are made publicly enter the public database, which is then freely available under Open Data Commons Attribution License, or ADC-BY license, which is very open. Our code is also open source and on GitHub on the AGPL license. And if you are interested in checking this out, well, we have also good first issues to get people started. But we do ask people to read this contributing that MD file and to get in touch with us. Okay, so I want to talk now more about one of the big challenges of such a project, which is security. So whenever you have an open platform like this, when trying to be inclusive, you try to integrate everyone, of course you're going to be then vulnerable to potential fake accounts, and as we have seen, this should be regarded as extremely common on the internet. So in particular, I'm going to talk to you about the two most critical aspects for security that we have, the 2 biggest issues, and how we are addressing them. So one of them is called Sybil resilience. So Sybil resilience, for those who don't know, is the problem of fake accounts, essentially. The fact that if it's very easy to have an account, then an attacker can create a lot of accounts and then make it look like the majority believes X or Y. This is a big issue in any participatory system, and it's been studied a lot in the case of cryptocurrency, with solutions that are not always very satisfying, let's say. They can be extremely polluting, typically proof of work, or they can be not really democratic, like proof of stake. So the one thing I should say is that all contributions will be taken into account by our algorithms, but in order to protect ourselves against fake accounts, in particular an individual who creates a lot of accounts at once. What we are doing is that the score for each, when computing the score for each video, what we are doing is that when the video is rated by a lot of not sufficiently certified accounts, then the voting rights of all of these uncertified accounts combined is restricted and then divided among them. So this prevents a group of trolls from controlling the score of a video because their voting rights will be limited. So we're still inclusive in the sense that everyone is affecting the scores, but we're getting this security by saying that, well, if too many uncertified accounts are pushing a content or voting on a content, then we limit their combined voting rights. Now, how do you get certified? So the main approach to get certified is through the first approach is through the email address. So we had this system that was that is mostly initially, especially, we was almost exclusively centered around the idea that we would want email address with domains that are Sybil resilient themselves. So typically, it cannot be like a Gmail or a ProtonMail account because anyone can easily create a Gmail account or a ProtonMail account, and more dangerously, anyone can create a lot of them. So instead, we rely on trusted domains. So what we call trusted domains are like domains we suspect are not going to create a lot of fake accounts. So this can be typically university or, like in the case our association, because we control it and we trust ourselves. But it can be also like big corporations if we trust that these big corporations are not going to be creating a lot of fake accounts this way. So this is one way, one way to put a first stamp on some accounts, and then we rely on a vouching system, so anyone can vouch for somebody else. And usually, if you are trusted and you vouch for somebody else, then this person gets slightly trusted as well. Not fully, because there's always the risk that someone has successfully created an account with an email domain, a trusted email domain. And they may then vouch for a lot of fake accounts, and this could be dangerous. So to avoid this, we have a Sybil resilient algorithm that is going to assign voting rights, and it's essentially based. So here, is typically an example of a vouching graph. So an arrow means that one person vouches for that the other is a real account and not a fake account. So technically, it's more like you're vouching that the other person is a real human that is not engaging in Sybil attacks, so it's not creating a lot of other fake accounts. And once you have this graph, this vouching graph, essentially we have something like PageRank. Essentially, you imagine a random walk on this, and one technicality is that the random walk is every now and then reinitialized at the set of trusted accounts. So these were the email certified accounts. And then the voting right that you get is the result of this random walk, how often the random walk goes through you. It's a bit more sophisticated than this, but these are the basic ideas. Okay. So another thing I want to discuss is the voting right, the voting algorithm itself, and how we make it secure. So one tricky thing about this is that so we assign a score to each video based on the contributions of our contributors. But then the video that's most recommended are going to be the ones with the highest score. And if you don't think too much about this, that there's a risk that someone realizes this, and if we have poorly designed algorithms, then they may take very bad videos, and they may have try to score them very, very high. And if they are the only ones scoring this video, then the algorithm may think that this video is indeed very, very, very good. So typically, typically one bad idea would be to take the average of the scores, because if a video, let's assume that the score was computed with the average, of all of the scores that the contributors think the video should have. Then one issue is that one malicious account that gets certified somehow, or even if it's not certified, what he can do is he can take the worst kind of videos on YouTube, bring in our Tournesol, and score it, and they would be the only one who's scoring this video. And because they are the only ones scoring this video, the score of this video could be very high. And if you have bad people that are very engaged in promoting bad content, as is the case for large-scale applications, then you can imagine that they're going to do this every day with a lot of content, and so most of the recommendations can end up being bad. So our solution to protect against this is like to have a voting right that's more robust, and it's based on an idea. So typically, imagine you have 5 contributors here, and they have different judgment of the quality of the recommendability of this video here. So typically, this guy thinks that this video is not that great, and the other thinks it's quite good. So how do we aggregate the opinions of all of the contributors? Well, our solution is related to a fable by an old Russian fable called the Swan, the Pike, and the Crawfish, where everyone was pulling on this car in a different direction, and the car was not moving because everyone was pushing in different directions. Now the conclusion of the fable is that this is not going well because everyone is pushing in different directions. But another way of seeing this is that this current position of the car is a sort of good compromise, because like everyone wants it to go in a different direction. Whereas if the car was very far on one side and everyone was pulling in the same direction, then the position of the car would be unsatisfactory because everyone wants to pull it in another direction. So at least that's what we brought into our algorithms, that the principle of our algorithm. So you can think that everyone's preferred score for this video, at everyone's preferred score of this video, you put a crawfish, and the crawfish is going to pull the score, the global score, the Tournesol score of the video towards their preferred position. So imagine every crawfish has a rope and they can pull on the global score. So if you do this, then in this example, you would have 4 people pulling towards the right and 1 person pulling towards the left. And the strength with which they pull is typically their voting right. So let's take an example where everybody has the same voting right here. Then you can see that in this situation, most people pull towards the right. So as a result, the score will be moving towards the right. So if the score is here, then now you would have 3 people pulling towards the left and 2 towards the right. There's a notion of fairness behind this, because it's like one person, one pulling force. Like everyone has a unit force, where everyone is equal in this sense. And so in this case, if you have this voting right, then these pulling forces, then the score of the video will be moving towards the left. In fact, the equilibrium would be here, because in this position, you would have 2 people pulling towards the left, 2 people pulling towards the right, and you would have this guy who's at its preferred position, so it will be just pulling close to itself. So in a sense, both left and right, where the sum of the forces would cancel out, and thus it would be an equilibrium. I don't know if you can guess what this equilibrium point is from a mathematical point of view. So this is actually equal to the median. The median of a data set is one point which separates the data set into 2 parts with equal number of elements in both parts, 2 on the left here and 2 on the right. Now, the median has been very studied a lot in secure machine learning, because it has this nice property that the majority is winning in a sense, and cannot be a minority cannot do harm against a majority. But in our case, it's actually unsatisfactory, because if I take the example of this bad guy that wants to promote very bad video, then if they take one very bad video on YouTube, import it on Tournesol, and if they are the only one who's scoring these videos, then they can make the score of this video very high if we take the median, because the median of one data point is equal to this data point. So to add some security to this, we just put everything in a parabolic valley. This way, if you have two people, let's say these were two malicious people who wanted to make the score of this video very high because it's a bad video, then because there are only two people, like they can only pull with two unit forces towards the right. And this prevents them from pulling too far towards the right because as the score of the video moves towards the right, the slope is increasing. So you need more pull to move it further towards the right. And so that's how we can prove mathematically that we have some strong guarantees about what kind of scores the video can have given a certain number of malicious contributors. So I want to talk a little bit quickly about a more general problem, which is security in machine learning. So here we brought security using our tricks, but the problem of machine learning security is much larger than this. And one thing I would like to stress is that machine learning so far has mostly been developed by academic research in like nice environments with like spectacular things. So it's really spectacular, but like security has not been treated with a lot of seriousness so far. And this is extremely concerning. And it can be very hard actually to move from this machine learning algorithm that works like maybe 90% of the time or even 99% of the time to an actual production system that is going to be deployed, especially on the internet, where it's going to be consistently under attack. So more generally, like the field that is trying to study the security of these systems in adversarial environments, like the internet, is called adversarial machine learning. And unfortunately, so far, practitioners report, I'm quoting Wikipedia, practitioners report a dire need for better protecting machine learning systems in industrial applications. In particular, like in industrial applications, you have to expect that malicious people are going to try to bias your algorithms or to make them fail or to evade them if it's a fraud detection algorithm. And you need to have ahead of time protections against this to detect the possibility of these attacks and so on. And so, and unfortunately, like here I'm going to talk about two possible very dangerous attacks. So the one on the left is planting undetectable backdoors. So it's been shown that it's actually quite easy. So there are very almost straightforward algorithms. You can take any machine learning system and plant it a backdoor, and then the backdoor remains in the system. And this is especially concerning if the computations are not done by yourself. So what happens a lot in machine learning typically is that you need a lot of computing power. So you ask like a third party, like Amazon Web Services or Google Cloud or something like this, or Microsoft Azure, to do the computation for you. But then it's possible for this other entity to plant undetectable backdoors. And these are probably undetectable backdoors in a very rigorous sense. Like essentially, it means that you need exponentially many queries to the system, assuming under cryptographic assumptions, so like P different from NP, for those who know. So essentially, you're not going to be able to detect that there was a backdoor that was implanted in your system. So that's a huge vulnerability issue in critical, like if you deploy things in critical systems and using like the servers of a company from another country, typically. Another important vulnerability that has been exposed also recently is the fact that in machine learning it's very common to download everybody else's models and use everybody else's data sets. Using and this is actually a huge vulnerability because whenever you're doing this, whenever you download these things and you run the canonical, like the basic algorithms that are used, then there's a lot of arbitrary code execution going on. And so there's a huge risk that on these platforms, like a lot of the models are like uploaded, or a lot of the data sets are uploaded by malicious actors. And this may then run arbitrary code on your machines, or on the machines or your colleagues. And this arbitrary code can typically steal all of the data of your company, or like whatever, like the laptop or the machine that this has been installed on has access to. It can also paralyze systems and so on. So this can be a very dangerous vulnerability. So we have this company called Kelikarpa where we're trying to propose solutions to defend against this, and we also have we can also accompany data science teams into understanding these risks in machine learning security. So let me move on now to the conclusion. So I hope that I've convinced you that these security issues really have to be taken seriously, especially in these days and ages where you have a lot of geopolitical tensions going on, with a lot of interest of parallelizing of cyber warfare or taking over control over what are the ideas most promoted in a society, in other countries, and so on. These are like planetary risks, arguably. So we really need to take all of this into much more seriously, to pay much more attention to all of this, to secure a lot more systems, and to defend against potential attacks from even from authoritarian regimes. Now, in order to do this, like Tournesol is like a first sketch, arguably. There's a lot of things missing. We really need a lot more development, a lot more contributions, a lot more ideas, and this requires a lot of help from a lot of different people. So typically, one kind of help we need is like people contributing to our code, people contributing to our data set, trying to identify collaboratively top quality content. We need at least to set ourselves the goal of trying to clean up the web and make sure that things are much safer for everyone. And so for this, we need all kind of help. And if you want to know more about this topic, then there's a lot of things that have been produced around this. So there's a book I co-wrote with a Google researcher and Mahdi Hamdi. If you want a more fun version of discussing these issues, I also wrote a science fiction book with a medical doctor called Smart Poop. And if you want to know more about Tournesol, well, we have a white paper, and we also have like I also produce YouTube videos myself on the channel called Science Forum. And with this, thank you for your attention, and I'm happy to take questions. Yeah.
The Tournesol seems to be a user-governed solution. Does a regulatory or legal counteroffensive is possible, or you absolutely don't think it would be possible to regulate the algorithm?
Yeah. So the question is about regulation, and I think it's a very important topic. And there's a lot of progress that has been going on, especially in the European Union. So you have the Cyber Resilience Act that has been proposed recently. You have the Digital Services Act and the Digital Markets Act that tries to regulate especially things on the internet. You also have the AI Act that is trying to put demands on especially security of machine learning systems. I think these are all extremely critical. And we have to move hand in hand with the legislators. Right now, I'd say that the focus on recommendation algorithm by the legislators is insufficient. There's demand for more transparency, especially the Digital Services Act. There's demand for security and audits, especially the Cyber Resilience Act. But there's also a need for more tools to actually do this. And in particular, I would say tools for algorithmic governance itself, like influencing directly the algorithms in a collaboratively and easy way. In particular, what we would hope is to have collaborations with entities like World Health Organization, or even like maybe the European Union and stuff like this, to have their own inputs into what the algorithms should be promoting in the case of recommendation algorithms. Yeah, so like we have to work, like we cannot wait for the regulators to do their things. We have to, I think we need to ideas from both sides and communications between the two. Yes?
Do you think this mechanism of human contributors is sufficient to scale to make an actual impact, considering the amount of content that's created?
Yeah, so the question is about like scaling the impact given the number. Yeah, so actually initially like there was even like it all started during the early phase of the COVID pandemic, and so I was like terrified by the lack of attention given to COVID, and I actually sent messages to some of my friends working at Google, and one of them at some point replied and asked me what do you think should be recommended. And it's a task difficult for one human to find all of the quality videos. So that's why we had the idea of like essentially crowdsourcing this, having a lot of people identify the top quality videos. But of course, like even if you have an army, like right now we're not yet an army, but if you have a lot of human people like like reviewing the videos, it would still be insufficient for like new videos that have just come up or like many videos that nobody has seen yet. So that's where there's a lot of interest in doing generalization. So typically you could have a machine learning algorithm. So we don't do this yet, mostly for security reasons. But you could have an algorithm that's trying to learn, typically based on my data, for instance, what I would probably think of a new video that I have not actually watched. So you would have this algorithm doing the generalization for you. So I sometimes talk about algorithmic representatives. So like in representative democracies, like you elect representatives to vote ideally as you would be voting like on laws that you have not read. But of course, like representative democracies have all sorts of issues. One of them being that a single human is supposed to represent many like voters, so that's a bit complicated. He should know also like what their views are, which is also very complicated. And the politician should not be corrupted, which is also complicated. And so the hope is that if you replace them with algorithms that are well designed, maybe we can do a better job at this. But this requires a lot more tools, data, and research. Yeah.
Don't you think that people installing your application are already quite aware of the problem, misinformation, when the majority of the population just maybe will not take the step to install it because they don't care?
Yes.
So the people that needs to be reached will not be.
Yes, so the question is like, will people who should be reached by this system be reached? And so I would say that there's a lot of behavior change among the users already. So I think the system already has value for those who actually register to the system, so like a very biased sample of the population who are already concerned about these issues. But me personally, I've discovered a lot of quality content and information this way. So arguably it already has values. But the hope is more like, right now what we're missing a lot is like credibility. Do I fully trust my own system? No. I think right now we don't have enough data, we don't have enough contributors, we don't have enough auditing. So we need to scale to gain credibility. We need contributors and so on. And once we have more of this, if typically like the World Health Organization wants to collaborate with us to enable them to identify top quality content, if you have all sorts of these entities, then as it grows, maybe we can have more legitimacy to maybe go through legislators or something else to then reach more people. Yeah.
You brought up the possibility of ranking individual posts, videos, whatever it may be. What role might the assessment of channels or whole accounts play? For example, I say I trust this channel or I trust that this account is a real person.
Yeah, so the question is like, what about judging like channels or rather than videos or something like this? So I think it's a good idea, something I'm not doing yet. Another thing is that we could be doing and that we're not doing, again for security reasons, like we want to, is to generalize. Like basically, like if one user keeps thinking that the videos made by this channel is very good, then you could generalize and say maybe like he'll think that the next video by this channel will also be good. So yeah, so these are things that need to be explored, but we haven't explored them yet. Yes.
As far as I can see, your recommendations are not specific to one person,
Yeah.
global.
Yeah.
But is it intended? Is it something that you plan to do? Because what should be nice for you might not be something interesting for me.
Yeah.
But in the meantime, if prioritzation is so
Yeah.
having group of people thinking always the same thing and always the same thing over and over again, what's your point of view?
Yeah. Yeah, so the question is about personalization, and so from a security point of view, it's easier, like it's safer to have one score, like it avoids like filter bubbles and stuff like this. So given that, yeah, I give a lot of importance to security and to build slowly, we're not doing any kinds of we're not doing personalization for the viewers. But there would be ways to do so. Even as the system is already, we ask our contributors to say which videos should be more largely recommended. But we also have other criteria, like how reliable the content is, how entertaining it is, how much it encourages better habits. And people may have different, assign different importances to the different criteria. So based on this, we could, well, like, there's already the option, but you have to do it yourself to personalize the recommendations. But yeah, going further, so one of them, for instance, is layman friendliness, which is arguably very important because, yeah, like some people may want very technical content and others not. Yeah, so there's already this possibility, but ideally maybe we would want to learn based on users' actual clicks, for instance, on the videos, what kind of videos should be more recommended to them while avoiding this filter bubble phenomenon. I'd say that we're not ready to do these kind of things in a secure manner, but this is definitely something that should be explored eventually. Yes?
Yeah, so I was just wondering what kind of steps Tournesol is taking to actually govern this process. Because if I open the app now, I will see 4 recommendations, and they're all by Deutsche Welle, which is a German-owned media station.
Yeah.
So that's if that is my initial recommendation, how do you prevent that from perpetuating in me only recommending those videos because those are the first ones that I saw?
Yeah, so well, I mean, we don't have a lot. We haven't thought much about diversity. Like there's not a lot of there's no effort. Well, there's a little effort, but not essentially no effort to have diversity. We're trying to avoid recommending always the same channel, but that's it. Like that's not much diversity. In practice, I'd say that if you look at the recommendations, they are quite diverse. Though there's a lot of climate change on Tournesol, but there's still some sort of diversity, like in practice. But maybe we would want to think more about this. I think it's related also to the previous questions about personalization and to avoid filter bubbles and stuff like this. The short answer is that we don't have solutions for this, or we haven't thought about this enough.
Yeah, because it could be very interesting to not look at subjects, but at people. For example, a big problem with the Russia propaganda is that the popular TikTok stars in Russia are actually perpetuating these ideas about the war.
Yeah.
And then younger people are watching those. But that's actually entertainment. It's listed as entertainment. Is that something you also want to do? Not just scientific videos, but also any video, basically?
Yeah, so any video can be compared on the platform. And I think it's actually extremely important to compare entertainments because, like even movies, like there's a lot, like in China right now, there are more and more movies showing how to save China from Western countries, literally. And for a long time in the US, the main movies were like fighting Russians. So there's a lot of propaganda in entertainment, and I think and there's also a lot of quality in entertainment that are like educational or like so. Tournesol allows to compare any videos on YouTube, and I think it's important to judge as well entertainment videos. Yes.
Regarding the general user experience.
Sorry. Okay.
You can answer more questions personally.
Okay.
Of course, but we have to set up for the next.
Oh yeah. Okay. So sorry.
You can do one more maybe.
Okay, maybe last one.
Regarding the general user experience, would you say this is a point where we can just randomly recommend it to friends, family, whoever, or do you think it's still better suited to somebody who's maybe already interested in the topic?
Yeah, I'd say it's ready for most people to be watching this. There's like clearly there's an intellectual bias, like the videos are maybe a bit more boring, let's say, than what you would really want to recommend to people who are really not interested at all in this. But I'd say it's ready. At least we're trying to push it already, and then we actually have a study coming up about trying to analyze the effect of having these kind of recommendations on the consumer's consumption habit on YouTube. Thank you for your attention and your questions.